Peters, who has done quite a bit of work in Agile and Java.net, author of a few open source things as well. So great person in the community. Enjoyed his presentation, and please, if you're going to leave, make sure you do put in your rating of the presentation as you leave. Thank you very much. Go ahead.
All right, thanks, Adam. So today's presentation is on DevOps. Just a quick introduction in terms of who I am. Adam said my name. If during the session, I would love to have your feedback. If you've got some questions, please feel free to raise your hand, interject. I also would appreciate any sort of feedback that you have on Twitter. So my Twitter handle is included at the bottom. I'm talking about my experiences at my company, Pulse Energy, and its Twitter handle is included there. Just a disclaimer for this presentation. My background is development as opposed to operations. Better? Okay. No, probably blocking you, Chris. You can see okay. So more of a development focus than an operations focus. But that's the nature of things. So what do we do? It's largely an experience report. I'm going to talk a little bit about our company. I work for a company called Pulse Energy. We build energy management software. So we're a web-based startup. We provide software as a service. What we do is we collect data from energy consumption information from commercial and institutional buildings. Via things like smart meters, we archive and aggregate that data in a central storage facility in our data center. We run various analytics against the data, and we present that data back to our clients, energy managers, facility operators, so that they can optimize the use of their facilities. So we help them measure and track savings, identify anomalies in the operation of their buildings, and then take that information, present it to the public, educate building occupants, and provide as much information as we can about energy use. Our objective is to build a product that provides some good in the world, given that a third of our greenhouse gas emissions come from heating, lighting, cooling, ventilating buildings. Anything we can do to reduce consumption there can have a positive impact. And so we deal with not just electricity, it's steam, hot water, natural gas, all kinds of things, all kinds of resources that are consumed within a building. And we try and walk the talk. So we use our software to monitor the energy consumption in our building. Now, specifically for today's talk, this is about our DevOps process. Yes, we do DevOps, and this is a bit about our experience. But one word of wisdom from Dilbert that kind of tie the two things together. According to the pointy hair boss, virtualization will save you electricity. So, if anything, moving your servers into the cloud, leveraging virtualization will help reduce energy consumption. That's one step in the right direction. So what is DevOps? Let's get everybody on the same page in terms of what this is about. Quintessentially, it's about building bridges between development and operations, getting the two collaborating more closely together and using the same language. So what's the problem? What kind of issues are faced within most organizations that are not practicing DevOps, that have a more traditional structure with a separation between development and operations? So one of the key issues is that developers tend to be, as they're isolated from the production environment, have relatively little visibility and less understanding of how the software that they're building actually runs. Conversely, operations have relatively little visibility into the product, may not understand the business domain very well, and their primary focus is just on keeping things running. This is a quote that I like from Eliyahu Goldratt, who's the author of a book called The Goal and the Theory of Constraints. He says, tell me how you measure me and I will tell you how I behave. And part of the challenge that we have with the separation between development and operations is the developers are generally measured on feature delivery. Whereas operations, on the other hand, are concerned about things like the stability of production environment, what type of uptime they're receiving. Obviously, the two are interlinked, but they're actually generally at odds because nothing will destabilize a production environment like a new release. So that type of tension within many organizations creates risk aversion to accepting new deployments into a production environment. And with the introduction of certain oversight processes like ITIL or Sarbanes-Oxley, it further encourages and deepens that division. So we end up with the state of the union, which is that we effectively have two groups that are not communicating and collaborating as well as they should be in order to effectively deliver software. Essentially, in this picture, what Dogbert says, in phase 1, a team of blind monkeys will unplug unnecessary servers, and in phase 2, the monkeys will hurl software, whatever is left. So the key thing to recognize here is that we are all monkeys. Whether you're on the development side, the operations side, the element of commonality is that we really are in this together. So what DevOps sets out to do is to tear down this wall of confusion between development and operations, get them working more closely together so that both groups can achieve their objective and unify the objectives, unify what they're being measured on. So really bring back the love between development and operations and bring back the agility between these two groups. So why is DevOps something that you should consider in your organization? Why is it something that companies are adopting? There's 3 primary reasons that I see. One is the objective to move faster than the competition. So if you've got a lot of bureaucracy and communication overhead between development and operations, it's going to slow down your ability to deliver new software, deliver releases to your customers. So encouraging that type of communication accelerates the delivery of new features. 2, in companies where technology is a business driver, having the separation between operations and development is really killer. And many of the companies that are active and early practicers of DevOps, they are companies that are heavily invested in innovative technologies. Developers need to understand how these new technologies are running the production environment. Operations may not have much experience with those technologies, so encouraging the 2 groups to work together is really the only way in order to be able to effectively leverage them. And in general, at least from a development perspective, there's how people think systems will operate and then how they really operate. At least for anybody who's had that experience where you don't have visibility into the production environment, you've been building up some software, and then you release it, you see how users really interact with it, you see how it really performs, it tends to be pretty eye-opening. So I think there's pretty broad appeal in terms of why DevOps is something that organizations that deliver software are interested in. So where does DevOps come from? Well, I think that there's 3 primary drivers that have brought DevOps to the forefront. One is web operations. So generally, startup companies that have achieved considerable success in delivering web products, generally some type of software as a service or decent e-commerce. Certainly all companies that you're familiar with. For these companies that are in highly competitive markets, they need to be able to release software very quickly. Some of them are releasing software multiple times per day. And in order to facilitate that, you just can't operate in an environment where you have a lot of separation between your development team and your operations team. They really have to work very closely together. So driver number 2 is the rise of cloud computing and managed hosting. So from a DevOps perspective, it means that at least the infrastructure layer in your technology stack has been outsourced to some type of third party. So if you're running in a cloud environment, like you're not concerned necessarily about provisioning specific hardware. You don't need to worry about routers and cabling and networking. A lot of that is going to be, or all of that is going to be taken care of for you by the provider. So that means that it's feasible to focus on fewer levels in the stack. So it means you don't necessarily need that hardcore low-level expertise, which makes it feasible for people, let's say developers, to gain more experience in terms of the breadth of their technology stack. So the third primary driver is the rise of Agile. I would have to say this, I'm at an Agile conference. But there are certainly certain things that are key enablers within Agile that DevOps supports. So number one, as we mentioned, is frequent releases. Number two, from a lean perspective, is really looking to extend the value stream. So incorporating more groups in the process, really thinking end-to-end with the delivery of software. So not just taking software from a perspective where it's built and tested, but actually deployed into a production environment and delivering value to customers. There's also influence of Agile concepts like test-driven development, percolating into the operations community, so you end up with practices like test-driven infrastructure. If you're interested in learning more about DevOps, I have the pimp Jez and Dave's book, which I thought would probably be for sale in the bookstore, but it's not. But there's a lot of great information about more efficient software delivery contained in this book. So it's not DevOps specific, but it definitely has a lot of great ideas that can facilitate a DevOps practice. So how to introduce DevOps into your organization? Well, I don't really know anything about your organization, so I'm just going to talk about our experiences at Pulse Energy. So your mileage may vary. Our implementation is obviously specific to our context. It may be quite different from other organizations that also have a DevOps practice. Ours is potentially closer to maybe a no-ops practice, so there's no dedicated operations people. Instead, developers have responsibility for deployment, for provisioning servers, for supporting the application. But based on I would say we've been doing this for the last 3.5 years. Looking back at our experiences, I kind of reflected and felt that there were about five principles that I felt were key to our DevOps practice. And they're accountability, transparency, consistency, redundancy, and leverage. So I'll go through each of these and talk about what their relevance is within our context. Any questions so far before I dig into some of these?
A bit off the topic here.
Sure.
Why is virtualization inherently more environmentally friendly?
I don't think it is. I think that was just that's the point you hear Boss from Dilbert, and he tends to make these kind of outrageous statements. I think it's probably more the opposite. I mean, you could maybe make one argument that you're sharing the same hardware with other companies that are running their own applications on the same physical box. So from that perspective, maybe there is some energy savings that can be realized, but
it's a better utilization of idle time.
Okay.
Because you share your idle time with other people to use it rather than having to do nothing. So.
But the reality is that for like part of the reason that Amazon got into this was that they had a lot of idle capacity. They'd already built, like it was essentially a sunk cost for them, and they were looking for a mechanism to monetize it. And so a lot of data centers will have excess capacity anyway. So I don't know. I don't know that there's been any specific analysis. I think it's you could probably make an argument one way or the other. Okay, so in terms of accountability, what's meant by this? I mentioned a few things here already, but within our context, and I think for most companies that have a DevOps practice, developers are involved in doing deployment. Deployment is not something that is just passed off to an operations team, where the operations team has to, work some sort of out-of-bound hours in order to get the software deployed. So the developers are there to do the deployment, or at least to collaborate with the sysadmins on getting their software deployed. It is a key part of their responsibilities. What this tends to encourage is automation of the deployment process. So for us, our deployment is fully automated. One command that's executed, and the latest version of the application will be rolled out to all the servers in our data center. So another way to provide joint accountability is to ensure that developers have responsibility for supporting the application. So that means that once the application is deployed, they can't just forget about it and move on to the next project, and meanwhile just kind of accumulate all of this debt in the software that they're unaware of because they don't have visibility into how it's actually operating in production. So for us, we have a daily support rotation. We just have a whiteboard calendar where kind of on every 2 weeks, people just will sign up for a specific day that they're available to be the first point of contact for any support-related questions. So we're effectively doing third-level support. So it's also, that's the go-to person for any questions within the office. So from our customer success team, if there are questions that are of a technical nature that they need to really have somebody to direct to, they'll go to the support person internally. But it just means having much greater accountability, alignment of accountability between the people that are building the software and the people that are supporting it. So tying in with some of the talks that we've heard so far at this conference in terms of growth mindset, Johanna talked about it, Linda just talked about it. I think for this to be effective, it really means having a team that is ready to embrace being polyglots. It means familiarity with tools, with environments that developers on the team may not have otherwise been familiar with. So providing some incentive, encouraging people to learn about these tools is going to be key. For us, we haven't had, most of the people on our team have not had a lot of operations experience. So we've hired some people who have effectively coached other people on the team in order to get them up to speed. And once that knowledge is gained, then it's spread very easily. From a measurement perspective, so going back to the quote from Ilya Goldratt, really it means changing the way in which the team is being measured. So it's more than just delivering features. It's ensuring that everybody has some accountability for the stability of the production environment. So having a shared support rotation is key there. But with a high focus on measuring uptime and visibility into system uptime is key. So this tends to encourage other practices like zero downtime deployment. So development tends to want to deploy more frequently. Operations tends to want to have a stable environment. What you have, when you bring those together, you end up with zero downtime deployment. And it's the only way to be able to get features into production in a way that is not going to require scheduling and overhead. So for our context, we've had zero downtime deployment for quite a long time. We have it both in our production environment and in our test environment. We use the same deployment script in both environments. So that means that we can deploy new builds to our test environment pretty much continuously throughout the day in a way that has no impact, is not disruptive to testing activity. So that's key. because that means that you can be testing the software continuously. There's no scheduling of deployments, and it means that you are testing your deployment process. You're testing that users will have no interruption in their experience when your release gets rolled out. So one thing about having this type of process that's, I think, a little different from a standard operations process is that it means that a lot more people tend to need to have access to various production environments. So having some mechanism for doing account management is key. We use a third-party tool called PassPack for managing all of the accounts that we need to access, including accounts for production servers. And so that's provided a very kind of convenient and centralized way to manage accounts. But in general, for accessing specific servers, what we tend to rely on is each person who has access has an individual account. It's a very limited access account, and any sorts of administrative commands that need to be run on specific servers are done through sudo. So very fewer people have root passwords specifically. Administrative accounts can be, or administrative commands can be run through sudo. Individual accounts, if we have people leave the company or whatever, then it's just a matter of terminating that specific account. We don't need to worry about changing all the root passwords because somebody's left. So that information is a little bit more controlled. And so in general, just access to the production environments is controlled through SSH keys that get distributed using some of the configuration tools that I'll talk about in a second. And so in general, in terms of changing accountability, our focus is really on measuring user value. So getting the entire team unified around what delivers value to customers and being held to account to that. So for all that accountability to work, it really means that there has to be broad visibility into the production environment. People need to understand how things are running in production. And so transparency is a key thing for us. One thing that we have in our team project area is we have a large flat screen monitor that's mounted on the wall that provides general project status and status of the production servers, so we can see what servers are running hot, whether or not there's been any outages, on top of just general information about project health. So like work queues in our issue tracking system and commits, etc. And building these types of status board like this is just something that we knocked up in an afternoon. But this information radiator is really key to just the rhythm of the team, the operation of the team. If this is something that you don't have in your team area, assuming that you're working in some type of an open work environment, I highly recommend getting something like this set up. So on top of this, we leverage a variety of different tools to provide system monitoring information. So some of the tools we use are Ganglia, Scout, Monit. Ganglia is used by a lot of large web companies. If you go to, I think it's Ganglia.wikipedia or wikimedia.org, you can see all of the Ganglia stats for the servers that are running the Wikipedia site. So this is kind of what Ganglia looks like. It's organized into, you can organize things into clusters and then dig into specific servers in order to get more information. But generally we use it to track any system level metrics, so load, memory consumption, disk utilization, to application specific metrics that are collected by the daemons running on the servers and then pumped into their database. Scout is something that we've been trialing. Chris and I were talking a bit about this yesterday. It's certainly much easier to configure than Ganglia. Ganglia is a little tricky to get going. So Scout is a hosted offering, as opposed to trying to run this monitoring yourself. What you do is you transmit And so it collects a lot of that monitoring information for you. For things like site monitoring, we use Pingdom, which is fantastic. If any of you run a website, even a personal website like a blog, check out Pingdom. It's free for, I think, for one site that you want to monitor. And so effectively what it does is it's just pinging your server from a variety of different data centers around the world on some sort of an interval that you specify, and then it will provide you with notification in terms of whether or not that there's a problem. And this is something that you really want to have a third party do. Like, you don't want to be leveraging your own servers, your own data center to validate whether or not things are working. So it gives you a sense of whether, I mean, sometimes you end up with alerts that will tell you that your site is not accessible from, let's say, Munich or Singapore, which is maybe not relevant if you're not doing business in those countries, but if you are, it's extremely valuable. In terms of error notification, so anytime there's an error that happens within our applications, we want to know about it. What we have is the tool on the left, Logmaster, is a utility that we've written internally. It's just a daemon that runs on each server that receives a stream of log messages piped to it over a socket. Anytime it receives a warning or an error message, it will email us what the error was, what the stack trace was. So our entire team gets notified pretty much any time errors happen within the site. Now, there is some throttling that's done by the daemon, as we discovered early on. Without throttling, you can very quickly overwhelm your inbox, not to mention become labeled as a source of spam and get blacklisted, which Google did to us. But what it does do is, it encourages very fast response, because you get notified as soon as problems happen. Often, they're problems that users aren't even aware that they've encountered. But when they do, it means that your support team can reach out to those customers and say, look, we just noticed you experienced this problem. We want to let you know that we're aware of the problem. This is our timeline for resolving it. Normally it's a couple of days, and the problem is fixed. The implication is that you end up with extremely clean logs. Just because you only really want to be notified when there's problems. But it's something simple that we put in place very early on, and we make extensive use of. So Airbrake is a third-party utility that does something similar. It aggregates log messages, provides notification. It supplies a web interface that looks something like this, so that you can see the list of errors that have been logged within your application, the number of times they've been logged, when they've been logged. You can use it to specify whether or not there's any actions that are to be taken based on these messages, etc. It's pretty good. The only thing that we don't like about it is that there isn't currently a mechanism to remind you. So if you have something an error that's happening many times, you're really only going to get notified the first time. So there's no kind of re-spamming. That means, and because we're relying a lot on our email for tracking these things as opposed to going into some alternate website to look at what's going on, we find that we prefer having just the regular email notification. But I mean, this is very useful from an aggregation perspective, so you can actually get a sense of like how often a specific error is happening, rather than trying to troll your inbox to find that information out. So we can use that as a means to do prioritization of which issues we're going to address. Has anybody tried something similar with their application, like being alerted any time there's an error that happens?
We use the stack from Loggly, so they have Loggly and logstash, open source tools, pretty similar, and Greylog 2 as well, which is more like Airbrake, but you have to install it yourself. Yeah.
So you host the application?
For Greylog you do, yeah, and Greylog is compatible with agents, with the logstash agent or other agents, so they send the data. It works really well. And it's Splunk as well, which is a commercial tool.
And I think the idea, like, we've been, part of the reason that we've been looking around at alternatives is, even though this daemon works really well for us, it's still some code that we have to maintain. And And if there's a third party, especially an open source tool that we can leverage instead, then so much better.
I think for the one you custom wrote the log master or something,
Yeah.
I think you could replace that with logstash probably like really quickly.
Yeah, I'll take a look. So in terms of other types of tracking that we do from a visibility perspective, user tracking done within the application, we primarily use Google Analytics, partially because it's free. There's a number of other user tracking tools that we're also in the process of evaluating. But again, if you want to measure your performance on the basis of user value and user activity, getting a sense of how users are interacting with your software, what type of retention you're having, what type of activity you're having, those are kind of key aspects of reporting, and these are some useful tools for doing that. Okay, so coming on to the next principle, consistency. So one of the things I think about in a DevOps context where you have to share the knowledge much more broadly about the configuration of different environments, consistency is crucial, right? Because there's just really so much that people can hold in their heads. And it produces obviously some side benefits in terms of having environments that are configured identically. So ensuring the test is a really close reflection of production. To do this, and this is kind of a key part of the DevOps practice, is a recognition that configuration information is code and should be treated as such. As a result, it should be kept under version control. So what we're currently using, and I'll talk about these tools in a sec, is we're using tools like Puppet and Chef. But I want to go through where we started, because for companies that aren't currently using these tools, there is a way to, at least a way that we kind of moved into taking on that additional complexity. So with the recognition that is source code, our first step was just to get everything under version control. And then on each server, we just checked out the configuration from our source code repository, and then provided like symbolic links into the various applications so it would reference the configuration files from source. And that was like a super easy thing to get started.
Is it configuration of, let's say, Tomcat Apache, or
Yeah.
is configuration of your application?
Everything.
Yes.
Yeah. So Tomcat configuration files, Nginx configuration files. We have like Etsy hosts. Pretty much any of the files, any of the text files that you would need to change by hand as a product of provisioning a new service, just put into version control. So that was very simple. It doesn't help, at this point in time we were still installing all of the applications manually after the fact. We had some scripts to support that, but this was just kind of a quick and intermediate step that we took. We would have a cron job running on every server that would effectively do diffs from source control to indicate, what configuration had not yet been applied to a specific environment. And so then, when we went to apply configuration to an environment, we would just do a checkout or an update.
But usually there is something specific about this particular box, let's say IP address. So basically you have to take it from source control and replace something, right?
No, so we would have one file in source control per node.
Oh, I see.
So, and keep in mind, this is just where we started, okay? This is not where we are right now. But just to provide a sense of what kind of evolution we went through, and for companies that aren't doing something like this is something very easy to get in place. Effectively, what you can do is you can go to each server and just find all the configuration files, check them into source control, provide symbolic links to reference the folder that it's under, and you've now versioned the configuration for your environment. So subsequently, we've moved on to using Puppet and now Chef. These are also big parts of the DevOps movement. So tooling is kind of a key part of DevOps. I'm going to talk about each of these in turn. But effectively, what they allow you to do is automatically provision new servers. So from a set of cookbooks or other recipes, it allows you to build up a new node automatically. And so that if you're running in a cloud environment where your nodes are not necessarily very stable and where you need to be able to provision and spin up new nodes quite quickly, then having this type of capability is pretty key. So again, to give you a sense of evolution, I think there's kind of two models that are typically used when doing automated provisioning. One is push, one is pull. So push is where, pull is where we started. So, push is where we started, which is basically you push configuration out to a specific server. So you go to that server, you say, okay, I'm going to apply the configuration changes to the server. And so it's something that is initiated by a specific action. Whereas pull is the server is running some type of a daemon that is checking with your central configuration service for changes, and when it detects that there are changes, it will automatically apply those changes to itself. So when we started using Puppet. We were new to the approach, and we wanted to have a lot of control over how configuration changes were being deployed. So we used very much a push approach. So we were applying changes into our test environment. We would either go to each server or via Capistrano apply changes specifically. Whereas we've now switched to a pull-based approach, so our servers are upgraded automatically. But that's required a little bit more work.
What's the advantage of push?
Well, as you've got a lot more nodes, relying on pull is much more scalable. So the servers take responsibility for upgrading themselves. Also, when you're in a cloud environment, your nodes may be changing more frequently, so there's less overhead. Effectively, with a server provisions itself, using one of these tools, it's running a daemon, connecting to the configuration service, it will upgrade itself. So it's really less hand-holding, assuming that you've set everything up right on it. Yeah.
So your configuration server is somehow tied to your source control.
Yes. Yeah. And that is key. I'm sorry.
So I assume the pull part of the code is starting to pull.
Yeah.
Has to be tested.
It does have to be. Yeah.
So it's part of the code pull, not necessarily the server code, but also the configuration code that's going on.
Yep. So we would pull the code in. We would do effectively. I mean, this is with the traditional model of having all configuration in under source control. For each server, we would apply that change, and so we might do it first in our test environment in order to validate the change, and then we would do it in the production environment.
So you're testing the configuration code and the end user code.
Correct. But they can be tested independently. So just to talk about, quickly talk about Puppet versus Chef, there's a few differences which are useful to recognize. One, Puppet is, it takes a declarative approach to configuration. So everything is specified in terms of what should be running in that environment. And to do that, it uses a DSL for describing configuration. All of this is, both Puppet and Chef are built in Ruby. So it uses Ruby as the underlying implementation of the DSL. Puppet supports both push and pull, which is kind of partially why we started with it, and it's an older product with a larger install base. Chef, which is slightly newer, takes more of a scripted approach to configuration, which developers tend to like. You can treat it more like a library for doing deployments. It also allows you to explicitly specify the order of execution that changes should be applied. That was one thing that we struggled with in Puppet, was ensuring that, let's say that Nginx was deployed before Tomcat, and that certain changes had to happen in specific orders, and that was a little bit more difficult to manage with the declarative syntax. A big part of the reason that we switched to Chef is that it's got more momentum behind it, and it has better support for a cloud environment. So as we were deploying instances to AWS, we wanted to, Chef just seemed to be a better fit for that. So we've switched over. Well, one thing that we did find, so for those people who are looking at considering these tools, one thing we did find was that going with Puppet or Chef pretty much meant re-imaging our servers. So we needed to, because you pretty much want to have the entire environment built up using those tools in a standardized way. So so that was something that we did, was when we went to move to each of these, we incrementally pulled servers out, re-imaged them, rebuilt them using these tools, and then moved on to the next server.
Are you using images after that point? Like after you have whole structure satisfied by those tools, do you use image, or every time new node is reviewed from scratch?
So the trend seems to be with tools like Puppet and Chef are to just use fairly basic images.
Mm-hmm.
So the image will generally be just the operating system, and then use Puppet or Chef for everything else.
What's the advantage of this?
Well, the advantage is that there's less overhead associated with managing images.
Mm-hmm.
The downside is it does take a little bit longer to provision the environment, so it kind of depends on how long you're prepared to wait for an environment to be configured when you spin it up. And it also depends on how stable your environment is. So if your environment is really stable, then incurring some overhead in terms of taking snapshots of the image can be useful. The other thing that's a little tricky with images is that it is the difference from server to server. So because there are going to be some subtle differences in configuration, which Puppet and Chef will take care of, where that's more difficult to manage from an image perspective. So with regard to your question about testing these changes, all of our infrastructure changes are tested as part of our build process. So we use New City, but it will attempt to validate those changes, apply them within the context of that build environment. And so that's also kind of a DevOps trend, is to have builds that are specifically focused on validating infrastructure code. Capistrano, I mentioned before, it's another great tool for ensuring consistency, in as much as, so Capistrano is a utility that allows you to execute shell commands concurrently on a wide range of servers. So it means you're not going to each server individually and executing the same command. From a consistency perspective, the benefit is it allows you to build up a recipe of commonly executed sysadmin commands. So you don't have the overhead at each time of thinking, okay, well, where is this service? What's the standard way to interact with this service? Instead, you've just got basically a library of commands, and then you can run it against any environment that you want. So it's worthwhile to look at. It comes out of the Ruby community, but it's useful for lots of non-Ruby projects. So one final point about consistency that I think is key that we did from an early point is really rely on production data. So have a process in place that allows you to move production data into your test environment, so that we know that when we're testing software on a regular basis, we are using data that is actually relevant and current. And so we have an automated process in place that brings the latest snapshot of the production database into the test environment, cleanses the data so that we don't have any customer PII information that we might expose or accidentally email customers from our test environment. But just from a consistency perspective, knowing that you can easily reproduce problems in production within your test environment, I think is key. So redundancy, next principle. So and these are more kind of architectural ideas, but they tie in with operations. If you've got developers that have support responsibility, there's really a high incentive and alignment of incentive in the people that are building the software, not to be notified, not to have to do any firefighting. So basically, you don't want to be the one carrying the support pager when it goes off at 2 or 3 in the morning. So for us, that meant redundancy across the web tier. So having the ability to kill effectively web servers and not have any visible impact to our customers. So having this capability obviously facilitates zero downtime deployment. Database replication. So on the database layer, relying on replication in order to ensure that there are redundancy at that point. Databases are always a big single point of failure. As a product of the replication process, we recently moved data centers, and we were able to do that without incurring any downtime, just by restoring a database snapshot in a different environment, setting it up as a slave, so it was getting all the most recent data, and then standing up the new environment, and then switching the DNS over to point to that environment. So key to supporting this is queues, so having the ability to allow data to back up when you are not in a position to process it in a way that doesn't incur downtime and no data loss is key. Having things like circuit breakers in place within the application, so if there are third-party services, which we leverage a lot of, that are down, that any types of problems there should not trickle through to the rest of the application, and should not even affect performance. So once you detect that they're down once, it should trip a circuit breaker and not, and then avoid that pathway from then on. So these types of failures don't ripple through. Feature toggles are also something that we make a lot of use of within the application. From an ops perspective, if they're in the event, which has not really happened very often for us, but in the event that there are, let's say, performance or stability problems associated with these features, then you've got the ability to flip those features off. That buys you enough time in order to address what the underlying problem is. So having this type of capability in the software is very useful from an operations perspective. It's also extremely useful from just a general business perspective. It allows you to incrementally roll new features out to a subset of your users, so to do some type of beta testing, solicit feedback, roll it out more broadly, and it's kind of a key part of our release management process. How many people know about the Netflix Chaos Monkey? Who's heard about this? So we're not quite at this stage yet, but I think it's a useful it's a useful story to tell. So Netflix a few years ago started moving their servers from a hosted environment into the cloud, and they're actually one of the largest services running in the Amazon cloud. And one of the things that you realize when you start running services in the cloud is that availability goes down significantly. So in order to mitigate the risks associated with loss of service, they implemented this little thing called the Chaos Monkey. It's a daemon that will randomly kill nodes in their cluster. And they do this. It runs continuously. I mean, I'm sure that they've got some sort of a threshold and it doesn't kill everything, but it will go through and it will just shut down nodes, and they monitor. And it's really their way of validating that their system is resilient, that they have redundancy for everything, that there is no single points of failure. So, a pretty neat idea. Obviously, it requires quite a high level of sophistication, but it's something to aspire to. So the last principle that I'm going to talk about today is leverage, and how leverage relates to DevOps. So the key thing here is we really want to have the ability to focus on our core competencies when building software. And most of us, even the operations people, are not experts in setting up and managing a data center. So it's kind of one of those key things that is now incredibly feasible and cost-effective to outsource. So for managed hosting, we use Rackspace. We also use a company called Onyx to have a Canadian data center because we have customer data that can't be hosted in the US. We use cloud computing and storage on Amazon. We did some cost analysis based on the cost. We collect a lot of data, and so the cost of data storage for us running in a managed host is about 100 times more expensive than hosting that data on S3. So we put in place an archiving process. So we send data through to S3 for permanent storage. The only thing that we didn't realize when we started down this path, that it's a stumbling block that I think a number of other companies ran into, is that it's basically free to store your data on S3, but it's not free to retrieve the data. And so, and we realized the hard way that you could if you've got any type of chattiness between your application and services that are pulling data from S3, it can get a lot more expensive than actually storing the data yourself. So it does encourage a re-architecting of your solution to do more batching, to really go there when you absolutely need to. But anyway, the tools are there to leverage. DNS, we're not experts in DNS, so we use Dyn DNS, provides fantastic services for DNS managing. It's really cheap. So I use it for my personal domain. Very affordable. Source control, we don't host our own source control environment anymore. After having a local Subversion instance that we never upgraded for a couple of years, we made the switch to Git. We said, let's just get up and get out. And that way, we don't need to worry about it. It's somebody else's problem. It's going to be more secure than our local environment because it's such a big target. And even if there is a security breach, the odds of people actually paying attention to our source is pretty small. They're going to pay attention to the source of some of the other much bigger and more important companies than us that are hosted there. Similarly, email, like we originally hosted our own email. We had our own email servers. After realizing pretty quickly that it's quite easy to get blacklisted as a spam source and very difficult to get unlisted, we went with the third party to say, like, you deal with email. Like, we just want it to get to its intended destination. We use a service called Postmark. It's got a RESTful API for sending emails to, and very inexpensive. Customer engagement, we use a variety. We have used and played with a variety of different tools for that. So instead of your own user forums, use one of these other services that are pretty affordable for managing all that. Even for the automated provisioning service, so we're using Chef hosts, we host our Chef recipes on Ops Code, so they take care of that. We don't have to set up our own Chef server. So, in summary, DevOps, it's about building bridges between development and production. And we do that by ensuring that there's some shared accountability between these two groups. The accountability is made possible by there being transparency, visibility into how the production environment is working. And the knowledge overhead is kept low by keeping everything consistent and redundant, so we don't get notified all the time when there are problems. And then we really look for opportunities to leverage things that are not in our core areas of expertise. So that, for us at least, has been a winning combination for delivering DevOps. Again, your mileage may vary, but thanks for listening. So any questions or comments?
Just wondering, I'm curious, you guys host all of your stuff. You've got some stuff on the cloud, but generally your data center is sort of managed by you, or it's you're in managed Rackspace?
Yeah, we're using a managed service.
And what are your feelings versus the whole kind of building out your own private cloud before
in time, we are looking to move more and more things to the cloud. At least when we were starting out originally, we wanted to have some type of guarantee around reliability of the environment, and because we didn't have redundancy. I mean, redundancy is something that you acquire as your system grows, and two, some guarantees around performance. So, and I think when we started, there was less knowledge, less information about cloud hosting, and so we also didn't have things like Popular Chef in place in order to automatically provision new nodes. And so we've been making this transition gradually, as I think many companies do. So you just kind of bite off little bits that you can do.
And sort of taking that to the extreme, have you guys considered sort of things like Heroku, where a lot of those options like setting how you provision nodes and stuff are kind of taken care of? Or is that, does that have too many disadvantages?
Well, I think for us, and maybe this is just our narrow perspective, but we want to have a good understanding of our environments. We want to ensure that our environments are consistent between between test and production. So we want to have the control to ensure that we understand that. And at least that's where we've started. It may turn out to be more cost effective to go with a third party that takes care of a lot of that for us. But I think that we're much more likely to just go the route of continuing to manage the servers ourselves, but have the nodes running in a cloud environment as opposed to on a dedicated host. What's been your experience? Have you stood up something production worthy on Heroku?
No, I've only done small stuff on Heroku. For our production stuff, we're looking at Azure, and so being a Windows environment is kind of an entirely different conversation. The tooling is very different. You don't really have things like Puppet and Chef or node control, and Azure is very specific in the way they manage things. So I'm sort of just curious from the other side what the perspective is of those different tools. So what people are seeing as the advantages and disadvantages. Because from our perspective, from my perspective, the less we have to do, the more we can kind of put on a third party that has expertise in that area, the more we can focus on what our core business is.
Yeah, I agree. It just kind of depends on how good a fit they're going to be for the platform that you want to provision.
Right.
So if your stack is totally standard, and it might be more standard and consistent in a Windows environment, I'm not sure these days. At least when we started looking to move, I mean, we're using. I think it's a pretty broad technology space when you're looking at running in a Linux environment as opposed to a Windows environment. Yeah. So there may be less specialization. Yes.
Could you share more experience on zero downtime deployment? Like how it's gonna work out with the thing that you talk about, like automatically push structure, like how to upgrade the server, how you put it out with zero downtime.
Yeah. So that's a good question. It's the way that it's set up right now with a full structure is there's kind of a rolling window for servers to check for configuration updates. So they're not all synchronized to pull configuration changes at the same time. For our environment, we use Nginx as front to our application server, and so Nginx within Nginx we can effectively redirect traffic to other servers. So when we're doing an upgrade for deploying a new version of the application, we're basically pulling that server out of the pool. You can also do it at the load balancer level, which is kind of where we started. But we found that within a managed host environment, we had less control over load balancer configuration. While you can set up the load balancer to do health checks to see whether or not it should remove the server from the pool, that tended to happen on a window. We wanted more immediate response, so doing that at a slightly lower level in the application was more useful. So having like a very lightweight reverse proxy server, lightweight web server sitting in front of your application server provides a lot of flexibility in that regard. We use it also to serve up static assets so that application server threads are not being consumed by serving images or style sheets or JavaScript files. So I've done some prior talks at Agile Vancouver where I've talked a little bit more about our release process and talked a bit more about how we've been doing zero downtime deployment. So, but if you're looking for more details, I'm happy to try and fill in. Yeah.
A couple of slides ago, you said that when you brought up the Netflix example, you said that most companies realize that when they move to the cloud, they lose reliability. We thought it was the opposite.
Well, on an individual node. Right? So that means you really can't have any single points of failure because the reliability of an individual node is much lower than what you would typically find within a dedicated host.
So if you were to move to a cloud at a single node, you would have a less reliable service? Oh, okay.
Yeah.
Is it just the nature of the cloud, or is it generally cloud solutions, or?
I mean, I'm not an expert on it, but my general understanding is that you probably have you've got less control over that specific server. You don't know how it's been provisioned. You don't know what else is running on it, so if there's any types of performance problems, they'll leak into your environment potentially, and often it's run on lower spec, more commodity hardware, so with a higher failure rate. So that's my understanding. Yes?
You mentioned that at some point your company was gradually moving towards cloud from dedicated. Could you elaborate on this process a little bit? So part of your servers running in dedicated and part on cloud, how are we connecting?
So the part of our system that we're currently running in the cloud is effectively a data archiving engine. But what we're moving is all data management into that type of a service, at least for time series data. So taking advantage of scalability, so being able to easily add additional capacity at relatively low cost, less expensive storage. And the other part of it has been for us that we're experimenting with some alternate data storage technologies. So in all likelihood, we're moving to Cassandra for data storage, and we want to, it's much easier to do that, to just spin up a node in EC2 and get Cassandra set up and pull some data in than it is to try and set up additional test environments. So a lot of this kind of test and innovation and exploration we're already doing in a cloud environment. And so as it's already configured to operate in that environment, then we need to use it.
We did a similar process, not with Cassandra, with Vertical. And we're suffering very much from slow connection between cloud and our dedicated, at this moment was dedicated environment. So do you have this problem? How you solve it?
We do have that problem currently, and we'll let you know as we work through it. But a big part of it has just been re-architecting things so that we're batching up requests, we're reducing the amount of chattiness between the parts of the application that are running in the dedicated environment and the parts of the application that are running and hosted on Amazon. Part of it for us, we know that for us to roll this out, we are going to have a split because we can't host customer data in Amazon. Amazon does not have a Canadian data center yet, and we have a specific agreement with our customers not to host their data there because of concerns over Patriot Act. So
at some point your database was somewhere else and the rest of your services on the cloud and they have to communicate.
Exactly, yeah. And so for all of but we've been able to kind of get around it by ensuring that for most of the real-time data that we collect, there's no personal information. not traceable back to a specific customer. So we can store that large quantity of data there and have all of the customer-related information in the Canadian data center. But it does mean that we incur the network lag for communicating. So that's the current approach. It is still, the path is still through the application servers. So some things that we've done is put some caching in place of requests. So it's all done using RESTful API. So we have Nginx serving as a reverse proxy, so it can cache some of the requests for a limited period of time. I mean, for us, we're still learning as we're going, and our cloud adoption is pretty immature at this point in time. Yeah.
So you showed us here you have built something like a status pool.
Yes.
So do you know any tools that is out there that can be run without us building them or something like that?
So there is a third-party service called Geckoboard, which I've come across recently that looks pretty neat. It's got plugins for a variety of different back-end tools, and so they would host the they would host the status board for you and provide the interface for it. It's got quite a nice-looking interface, but you would need to ensure that all of your systems that you want to aggregate information from are accessible to their service. And it does mean that you're paying a third party for it. For us, ours is just using jQuery to do a bunch of scraping of different web services, APIs, and just web pages that we have data on that we want to aggregate. And that was easy enough. And doing it all in JavaScript meant that we didn't need to basically build a server. It was just much faster just to throw it together using jQuery. Yes?
Do you have any experience with or recommendations for organizations where DevOps is seen as a bad thing? I recently took over a team that just before I took it over became a DevOps team. And that's 2 people in an organization with 400 odd developers and an ops team that does various things. So it seems to be that the situation I'm in right now, it's okay. Like DevOps is seen as the right move, but I don't see it spreading. It's hard to get buy-in doing these things for security companies. So doing things like cloud hosted things is basically off the table.
Yeah.
Custom tooling is kind of hard to push forward with such a small team and such a small area for me. I was wondering if you have any advice for sort of spreading the love of DevOps.
Well, my experience with DevOps has been exclusively at Pulse Energy. I've worked in a variety of companies before where developers and operations were very separate, and a big part of what I was doing as an Agile coach was helping bring these groups closer together. I mean, I don't know enough about your environment to make some recommendations. I think a big part is just providing opportunities for collaboration between the 2 groups, and ideally some sort of change in measurement to ensure that the 2 groups are required to work together more closely.
I think probably part of the problem is that the bulk of the organization doesn't really make sense as a DevOps group because we sell shrink wrap and things like that. But there are sort of selected pockets that do make sense. But generally things are sort of looked at as this is what the organization does.
Yeah.
One size fits all.
What about the installation management?
Sorry?
What about installation management? Do the developers collaborate on that?
As in like developing, installing on-site.
Creating the build.
During the build?
The installation management or build management, is that shared by your dev team?
Depends on which team. In the Vancouver office, yeah, we own all of our builds. In the rest of the organization, it's very much waterfall with separate release engineer or build engineers in a clean room doing all this stuff. So in the Vancouver office is quite far ahead in many things. So we are like developers who own the whole build. We give it to the team that pushes it onto the website for customers to consume. But other than that, it's pretty self-sufficient.
What about visibility into the production environment?
Well,
Are you able to see how things are running?
Well, production environment is customer environments. We don't, for most of our products, we don't have a hosted, like, we're not a website.
Yeah.
We're not a software as a service. We sell, to endpoint software and stuff like that. So it's much harder to see. But yeah, in general, for the company, there's almost no visibility on that.
So what my understanding is you have some mechanisms in place that transmit data back to your data center, right? Like for some of the network appliances.
Yeah, we've got statistics gathering. Yeah, so that's why I also manage a team that has most statistics. The email appliance team that gets a lot of statistics back. So the team is aware of those and does act on those. So yeah, that side of things is good.
Other questions? Yes.
You call yourself no ops.
Yeah. So no ops is it's a bit of a seen as being a bit of a derogatory term, and I don't mean it as such, but it's going to say that, or it came out of this spirit that, or this thought that maybe you don't need any operations staff if you're leveraging either infrastructure as a service or platform as a service. Then you can effectively have developers manage everything. You don't need any operations expertise. And this has created a reaction in the DevOps community. Well, it's created first a reaction in the operations community because they're saying, well, wait, obviously they feel a little threatened by this no-ops thing. And so DevOps people are saying, no, operations is good. We want, there is both the dev and the ops, and the operations experience is important. But for us, like we don't have any people that are dedicated operations or come from an operations background. Actually, that's not true. We have one person now who is like more specifically focused on operations, but he also comes from a development background that he's doing more of the operations work.
So it means your dev people do like all the puppet work or all the check work now.
Yeah. Yeah. And so a big part of it has been disseminating that information and getting everybody understanding how these things operate. But they're pretty quick and easy to learn. The nice thing about it is that by having that broad understanding has made it much easier for developers to say, okay, let's try installing this. So what's a recent example? So we use Redis and for a variety of different things within our application. One of our products was looking to use Redis as a queuing service and evaluating it relative to RabbitMQ. And so knowing how to configure things in Oven and Chef meant that they could just push that out to different servers and try it out.
I think that's similar to some other companies out there, like Heroku is one example where they don't have QA. It's not to say that there's no need for QA as a process, it's just that developers, everybody who codes does QA, everybody who does QA does codes, everybody who does deployment or any sort of infrastructure work writes code and vice versa. It's just everybody's sort of seen as a developer. They just may have specializations or expertise in one area or another.
It does require a pretty deep knowledge of the system, essentially.
It does, and that was kind of why I was emphasizing the importance of consistency and leverage, is because I think that reduces the knowledge burden. You just need to focus on the things that are really core to your business and know them well and have that knowledge disseminated as broadly as possible.
You mentioned the polyglot thing as well, though. Is that a really big challenge to, sort of a barrier to entry is being able to manage all these different scripting languages, coding languages and stuff, and keep them all together in your head?
I think it's been it's a shift in focus. I mean, I look at myself, my background, I've never been all that interested in hardware, and my focus has always been, I just want to learn the software. There's enough to learn just in software, but I came to realize that the software that I was building was pretty crappy because I didn't understand anything about deployment, anything about production environments, and how those things were operating. And so it was more a shift in perspective. I've been finding, like with co-op students that we bring in, that I think they're fortunate because we give them that type of exposure directly. Like they have the opportunity to deploy stuff into production. They pull the trigger themselves, especially in features that they build. Generally, for any new hire, we get them to do the next deployment because as we deploy every week, that tends to happen pretty soon after. monitor how their system is running in production. Like, I think it really helps inculcate the right type of attitude, the right type of accountability. And if you have that visibility into how things are running, or if you see things failing because of an action that you've taken, and you've got the ability, you're empowered to correct it, then I think that that's the best way to stimulate that type of learning. Mike?
Just judging by number of people in this room, it's looks like a lot of interest in Vancouver, but how many people in the room know about DevOps meetup? Yeah, I think it's, there's a couple of guys who started this meetup, and I think we do need in community more experience, more people participating in it. I went to one of the meetups, and I was the only guy in addition to organizer. So, and I talked to Chris Reed, who was presenting yesterday, and he had this meetup in Calgary, and have 40, 50 people coming. It's really coming, I think, based on what Owen is saying, and based on your guys' interest. I think it's really something that we all need to kind of get into, learn, and both on the development and operational part, how to deal with it. So I really encourage everybody to kind of get to this meetup, let this meeting going, and Agile is really going to help to get it started.
Other questions? Is anybody adverse to